image to look at, something to look at here. You get ready for the one on the exam. Now, what I did, which I think is going to benefit you, I have one worked out for you. I've actually taken it through the steps and I've worked it out for you. Then we, if we look at the worked out one, we're going to flip over and do one together on the other side, which is blank. So I thought I'd better do one to show you what I'm expecting to do it, okay? And then we'll flip it over and do one together. And then on the exam on Wednesday, you have one of these to do. Now, bear with me, please bear with me, because all this is going to start falling into place. It's going to make sense for us. Hart, Anna, can you guys help me pass these out? Guys, when I scored your last quizzes, I think I had 9 A's. If I get 9 A's in a class on the quiz, I'm happy. I did have 9 A's. I think 4 or 5 was the first score.
Thank you.
Bart, keep one for yourself and send it out.
I just lost my paper.
Okay. Now make sure you send it out for those who may not be here. Oh, you guys, here we go. This is gonna take a ton of time. So write yourself a note. You have one of these on the exam. Now, if you look at the one I worked out, you sort of go through it first and we'll jump to the other side and try to work this one out. Directions. Use completion of the square to write the given function in, look at this, in vertex form. I've done the erasing here, and I named what that form looks like. Name the vertex, intercepts, sketch the graph, and then other questions coming up a little bit later. It looks like this on your handout. F of x is equal to this. Looks like I do. Guys, you got the answers in front of you. Let's see how on earth did I get those answers. First, it's going to graph into a parabola. Yours on the test on Wednesday is going to graph into a parabola. Now, can anyone tell me the way it looks? Will the parabola open up or down? Down. So that A, that's my coefficient, is a negative number, less than 0. It's going to open down. So that's the first observation on this one. So on the side, I'm looking for, when I finish up, a parabola taking that shape. Now if it does take that shape, this is your vertex turning point. Please tell me, the way the parabola curves, is that vertex, in this case, acting as a minimum, like you saw over there before the break, or is it acting as a maximum? This is going to be a maximum. So when I finish up, you'll be able to find the maximum value of this function. No matter what you replace x by, we'll find the maximum that can come out. Certainly. Now, though, to do that, I need to put it in this form. Your textbook writes it like this. I think I did this on the handout. They say, please write function given in what they call vertex form. That's the way it looks. Now please tell me, if I can take my time to write the black into the red, can I, this right here, does that tell me what the horizontal shift might be? Does x subtract h as a transformation say shift somewhere horizontally? What does the k tell me in terms of a transformation? Is that the number on the end, does that tell me what? The up and down, vertical shift up and down? So I see the horizontal shift in this case would be h, and the vertical shift is up k. I wrote h as a positive to the right. So the way this thing's written, it looks like it's h K will give you the coordinates of the vertex. But first, you and I are going to take the black and turn it into the red, or I can't answer these questions. That's called completion of the square. So on the side, here's all the work required. We're going to take the black, and guys, I prefer this as a Y here rather than f of x. Just make it easier. Rewrite it, and we're going to use completion of the square to change it into the red. Now, what's wrong with the way this one looks? What's wrong with me trying to use completion of the square right now? The leading coefficient must be a 1. I think I showed on the handout a quick way to turn that into a 1, not very too much like I was doing before the break. It's just step 1, do this. Divide both sides by -2. Take this. Watch carefully, I'll make it as easy as I can here. It's called completion of the square shortly. Divide everything by -2. If I do, left-hand side, of course, is this. Right-hand side, if I divide all three of those terms by -2, and I'm careful, yes, a -2 over a -2 is a positive 1. That's what I want. I want a 1 coefficient. In the middle, 5 divided by -2, I'm right as a -5/2 x. And on the end, -3/2. That's the right-hand side divided through by each one of those three terms divided through by -2. I hope everything looks good right now. That's step 1. By the way, do I have the leading coefficient now to be a 1? Which means now I can now complete the square. Now I complete the square on the x's. So I would suggest step 2, this is the way to think about it. Let's move that 3/2 over to the other side. Guys, and I'm going to show you something to do here. We'll put a blank on this side. We need to isolate those x's and show I need to come up with something to add to that blank to make the right-hand side a nice, perfect square. That's why they call it complete the square. Now, can anyone give me a guess? Because whatever you put here, you're going to put on the other side here to also keep it balanced. That's why I put 2 blanks. Can anyone tell me what's required on that blank to make the right-hand side come out to be? And guys, I'm looking for something like this shortly. The right-hand side must be factored into a nice, perfect square. What's it going to take on that end, that blank, to make that happen? What number is missing? Because if you mess up on the number, you're going to mess up on the whole graph. Anyone tell me the number on the end that I need right here? Based on what we were discussing before the break. What do you think? Okay, a good way to do it is to take 1/2 of that middle term, which in this case, well, it's going to be a -5/4. Take 1/2 of that middle term. That 1/2 came up before the break. So I'm going to put a comma here. Don't stop there. Take that result and square it. And the square, guys, we end up with 25/16. I'm hoping 25/16 is the number required, we'll find out shortly if it is, to make that right-hand side turn into a nice, perfect square. We'll find out here shortly. But if I add it there, I must add it also here. I'll keep this thing balanced. That's why I put 2 blanks. A little different approach to completion of the square. Now, can someone in my class tell me, if we are correct, what does this right here, right-hand side, what does it look like as a nice, perfect square? And before you start guessing, I know and you know, if you were asked this, and the professor says, right there's a nice perfect square, you just quickly say, oh, professor, it's this. That's what you want, that's a square. Now, what's mine? What does this one look like? Who has an idea? I'll get you started, it's gonna be an X. It's gonna be a minus. And does anyone think they know what has to be on the end? here it was a 9, what might it be in my case? Would be a little strange. I think it is. Anyway. It's gonna be 5 over 4. And Michael, you said 5 over 4, why? Guys, if I do square 5 over 4, is that 25 over 16? There you go. And if I square the x, I'll put the x in there for you, that's x squared. And if you want to expand the whole thing out and check it, save you a little time here, if you want to multiply this out, like from algebra 1, algebra 2, and expand it out, you will end up with this also. But the big thing is, yes, you end up with x squared. Michael says if you square this one, you end up with 25 over 16, which I needed. So the right-hand side's done, it's factored. The other side, to keep everything balanced, I need to clean it up. So guys, we'll write this as y over a -2 plus, I'm gonna put my two fractions together with a common denominator of 16. So I have to multiply this by 8. And guys, we'll end up with 24 plus 25, help me out, is that 49, I think? Over 16. I put those two fractions together, that helps some. So far so good? Don't make a mistake. Now you gotta keep in mind, we gotta get the y complete by itself eventually. So I've got a little bit more to do. To get the y by itself, I would suggest you move this over. I'm running out of space. So you got y over a -2, and you're moving 49 over 16 over. So now you got this. As you move that 49 over 16 over, it becomes a minus. Got some strange numbers on this one. That's been moved over, so it's gone. I'm after y. Can anyone tell me the last step to find the y? I want this thing solved for y because the original in the black had y. What should I do to finish it up? Thank you. Multiply everything by -2, everything. 2's cancel on the left, gives you a y, which I want. On the right-hand side, please don't expand this thing out, just put a -2 here, and I'll multiply by, let me stick -2 here, so I'll not make a mistake. I'm multiplying everything by -2, this right here is done, so I'm not expand it out. This on the end is negative times a negative turns into a positive, and guys, I can cancel 2 into 16, get an 8, that's 49 over 8. We're hoping that I just blocked off, and I can't even believe it as a professor, that I just blocked off is equivalent to this. They look nothing alike. This and this, I don't think any student would try to convince another student, say, these two are the same. Sir, you're nuts. They look nothing alike. Those are the same. So why should I take that nice clean copy, this in the black function, and turn it into this? Because now I know how to graph it. Okay guys, before I jump in and now start graphing this thing, we haven't graphed it yet. Any questions on how to use that completion of the square? It's a tedious process. I mean tedious. I would expect the whole class to probably be with me at 4 o'clock on Wednesday. Probably ask practice again, one of these again, because this is tedious. If you have time, you may have time, you could actually do algebra 2 here and expand this out, expand it out, distribute it properly, and it should take you back to, look at this nice clean copy, this. Now why am I taking this nice clean version from across the street, middle school, into this, which they don't see over there, I don't think. Because this tells me how to move. Vertical shift, horizontal shift, how to find that so-called vertex, which is up here for us. Now, can anyone tell me, if we accept the red, where will my turning point coordinates be located if you think about horizontal shift and vertical shift? What does this indicate is happening here? My horizontal shift is described as what? X minus 5 over 4, which indicates you're moving in which direction? To the right. How much? 5 over 4. So that's 5 over 4. And then your vertical shift on the end, 49/8. I'll leave it just like it is. And there's the vertex. If there's no mistake. It takes a sheet of paper to do this. On the test, it'll take 1 page of the test. Do all this. We don't have the graph yet. But I know the turning point's here. So my turning point up here is, for the vertex, 5/4, 49/8. Now, here's the sad part. But we'll try to help you out. The sad part is, if you're stressed out taking the test to begin with, if for some reason you place the wrong number on these blanks, that's gonna mess the whole thing up. I'm gonna give you a little hint shortly to let you know ahead of time, did I put the right number on that blank? If you put the wrong number, you've lost 16 points. How are you gonna get the graph? If you didn't find the vertex. Okay, so be very, very careful with this. Guys, I hope, on the handout, is that what we had on the handout? Same answer? I think, didn't we? Okay, absolutely. Now, with that said, here we go. Please tell me, after all that, let me do this before I graph it. Now, flip it over and tell me what was the function given that I'm asking you guys to do here? F of x is what there? Help me out. So what name for it? What was f of x on the other side? 2x squared? Minus 5? That's a parabola. That's a quadratic. Now this one I know is the leading coefficient, called A. The leading coefficient is positive. And guys, if it's positive, the parabola should be, when I finish up to graph it, should be opening up. If it's opening up, you have the vertex down here. And in this case, you have a minimum value to work with. But let's go ahead and do the same process on the one we're working with on the back of the handout. Let's go ahead and do this. Let's do the completion of the square on that one. What's the issue? The issue is that 2 messes me up. Now, if you look out and you see a leading coefficient of a 1 in the original function, you've lucked out. That's going to save you some grief. Here, though, step 1, and guys, we'll write this with a y. I think it's much easier than f of x. I'm going to first divide everything by 2, and have step 1 to look like this. Y over 2. And if you are careful and divide all 3 terms on the right-hand side by 2 and simplify it, I think you end up with this. I gotta watch myself. Is that true? Now, is the leading coefficient now 1? So I can now complete the square. Now, to complete the square, step 2, let's move that 5/2 over, out of the way, and show I now need to add something to both sides and keep it balanced to complete the square. For you guys who have never seen this before, I know it looks crazy. What a little effort. Now, can anyone tell me what's required on that blank on the right-hand side to turn that right-hand side into a nice, perfect square? And I'll tell you what I'm looking for when we finally get it. It's going to look like this. And I'll tell you this much. It's going to be x minus something. Can anyone tell me what's required for that blank? How does one find the number? How do we find the number back here on the one that was worked out in your handout? I found it down here to be 25 over 16. How did I find it back there? We're going to take 1/2, there comes that 1/2. 1/2 of this number in the middle. What is 1/2 of 3/2? 3/4. That right there, put up here. stop there, is squared. You're going to end up with 9/16. My last one is 25/16. That true, guys? So that is the number, and be very, very careful. 9/16, do not let me mess up, is the number I need to add to make this work. Now, can anyone tell me on the right-hand side, finish it up for me, what is that nice perfect square? It's x minus what? 3/4. Done. Now, that's a square. That's completion of the square. The other side needs to be cleaned up. In other words, put these two fractions together. You guys will end up with y/2 plus, I need a common denominator of 16, multiply this by 8. Oh my goodness. So we're going to end up with 49/16, which I sort of think we did on this one. 49/16. I'm going to add those two fractions up. So far, so good? Did we mess it up some way? I got 40 here plus 9. Is it 49, guys? Help me out. Now, step 3, they want you to get the y completely by itself. Move that 49/16 over. I'm trying to solve for y. If you move it over to the other side, now watch carefully. And then if they want y completely by itself, multiply everything by 2. And therefore, the 2's will cancel on the left, which I want, give me a y. Right-hand side, 2 times that parenthesis, just rewrite like this. Do not expand it. And I'll throw in 2 here also, 2 times that last term. You could cancel 2 into 16. When you reach the last term, you will end up with minus 49/8. Wow. Don't walk up to me on campus and say, Professor, this is equivalent to this. Look how different they look. And who knows, I may have made a mistake. But look how different these two look. This is a nice, clean expression up here. Look how awkward this one is. Now, why am I doing that? Why am I doing that? I need to find the vertex. Now, does anyone think they know where the vertex or the horizontal shift, vertical shift is up here? No way. Can you tell me down here, though, where are the shifts here? Does this indicate there's a horizontal shift to the right? 3/4. And then a vertical shift, what, down? 49/8. You'll say, Professor, I see the vertex right quickly now. It's 3/4 to the right and down. That. If we have no mistake. Yes, no? Please tell me. Did anyone see that up here? You didn't see that? I didn't see that. Look at this. Now there's clean up here, it's clean copy up here. But if you look at this clean copy, you're not going to see this vertex. And I need the turning point. I'm going to graph this thing shortly. Now, before I graph it, here's where I'm going to help you. Oh, beautiful. Okay, bear with me. Please bear with me. Before I go any further, on the side here, I'm going to write a standard quadratic with your help, like this. If you ever watch this. Is that a standard form? ax squared plus bx plus c. This is a standard form for a quadratic. I'd like to add no numbers. I don't have a 2x squared minus 3x minus 5 in this. I have variables. But I'd like to do the same thing. I'd like to complete the square of this. Same process, but I have no numbers. Can anyone tell me what would you do first if you'd like to complete the square and in an attempt to write this in vertex form? What would you have to do first? Anyone? I'll give you a hint. What did I do first here? I divide by 2 to make that leading coefficient of 1. What must I do over here? Divide by A. I'm going to divide everything by A for a general formula here. See, my first step is going to be this. Go back and divide everything by an A. Be careful. So you're going to end up with y over A. If I'm careful with those 3 terms on the right-hand side, divided by A, the A's will cancel in the first term, gives me this. Second term is going to look like this. Third term, like this. It's the best thing to do. Everything divided by A. Now what did I do back here after I did that here? I divided everything by A2. I think I then moved the C over A, move that term over, and get ready to add something in order to complete the square on the right-hand side. In other words, I'm down to here. Now, can anyone remind me what did we do to find the magic number required on that blank to go further? What did I do here? We came up with a 9 over 16 was the number. How did I find it? We took 1/2 of this middle coefficient, right here, and then squared it. Now, can anyone tell me what am I going to do on this one? I don't have numbers, but same process. I'm taking 1/2 of what in this case? I'll do it in red here. Here, I took 1/2 of -3/2. Here, I take 1/2 of B over A. Same process. A little awkward with the letters. That's B over 2A. Put a comma, and then what I do back here with the numbers, after I found that, I squared it. Little process here. So guys, if I square this, let me take my B over 2A, and square it, I'm going to end up with B squared over 4A squared. Do we all agree? That's what should be on that blank. I hope. So here, B squared over 4A squared, B squared all over 4A squared. That takes me down to here, where we were. Now, directly beneath this, if that's correct, can anyone tell me what on earth does that right-hand side look like? It may look strange as a nice, perfect square. That's the whole purpose. Anyone tell me what the right-hand side would look like? Over here, it looked like this. What's this one going to look like? Let me guess. There we go. X for sure, and she's a professor. It's going to be a B over 2A. That will give me the right-hand side. Much like when I had numbers over here. Now, if that's correct, the other side needs to be cleaned up, as I cleaned up the one on the other side over here. Those 2 fractions, look at this, guys, awkward over here though. I put these 2 fractions together, do the same thing here. Now, my common denominator over here with numbers was easier, 16. If I want to put these 2 together, can you tell me what on earth would I use for a common denominator? Something like this. On this one with letters. What would the common denominator be? Right here, put these 2 together with a common denominator. Someone give me a nice common denominator. And you guys quickly gave me, where was it? 16 over here on this one. What's going to be here to put these 2 strange things together? I'll give you a hint. Big hint. It's going to take 4A squared for a common denominator. This fraction has it. My first fraction is missing it, so I need to multiply this by 4A if I expect to get 4A squared. Now those 2 fractions have the same denominator. At this point, guys, step 3, we have, let's not mess this up at this point. Step 3, we have y over a. These two put together, strange looking, but it looks like this. I'm writing like this. Negative 4ac plus b squared all over 4a squared. That's those two put together with a common denominator, the 4a squared. Now you're talking about mess? It's a mess. The other side, at this point, stays like it is. So far, so good? Now, step 4, we'll call it. Now, we're finally down to the conclusion. Now, you gotta get the y by itself, like I did here. And then we'll be finished. Guys, it's going to look awkward as you know what. What would you do first in an attempt to get the y, solve for y, by itself? What would you do first here? Here we moved, I think the 49/16 over. On this one, we moved the 49/16 over in an attempt to get the y by itself. What would I have to move over here? You look at this mess. You gotta move this over, which will leave me y over a. Now, when I move it over, I'm gonna be careful. I'm going to rewrite what we have, though. We have this squared. Now, when I move it over, some signs will change. This becomes now positive 4ac minus b squared. Right like this. 4ac minus b squared. All over 4a squared. That's that term right there moved over. With some sign changes. Wow. What's my last step to get the y completely by itself? I see one more step. What's that last step? Multiply everything by a. Much like what I did with numbers on the other side. A here, I'll throw in a here so I won't miss it. Guys, a's will cancel, of course, on the left, which I want, gives me a y. That's what I want. A's cancel. Here, just place a up front. B, this. Do not expand it out. The other side, the other term, when I finally reach that last term multiplied by a, I could cancel one of the a's out. A into a squared, and I'm going to end up with 4ac minus b squared, like that, all over 4a. Oh my goodness, let's make sure. Then we do the same process we did with the numbers. Now, here you are, leaving us soon to one of the universities. Anyone tell me, based on what you see right here, no numbers, that number over here. Anyone tell me the best you can, where do you think the vertex is located on this one? Last one, I sort of thought about horizontal and vertical shifts. Anyone tell me anything, any coordinate of the vertex based on this? Here, it came out to be 3/4 to the right. And down vertically 49 vertically. And I wrote like that. And that's my turning point. Can you tell me what on earth would this look like? That's be a shocker. What do you think this right here indicates? A horizontal shift to the left, how much? B over 2a. It's like this. Negative b over 2a. That came from this. Is it true? The other coordinate, back here on my note with this, the other coordinate is really that end term. They match up. What's my end term here? And that looks crazy. My end term here, my last term is 4ac minus what? B squared all over 4a. There's my vertex. vertex. You said, Professor, what have you done here? I've created a formula that if I do not use in my directions, use completion of the square like I did here, and I just say, find it, I'll be going to this. Now I'm gonna check it. Now, it looks strange. If this is a formula to find the vertex, we found the vertex with this lengthy process on this one to be that number there, or those coordinates. Now let's use the formula. If I go back and use the formula on the same problem, up here, no completion of square needed, just use the formula. Guys, the formula says to find the vertex fairly quickly, and let's hope that formula over there is correct. The vertex would be, first it says, negative b over 2a. That would be, in this case, I know what a is, you know what a is. A is 2. B is negative 3. C, if I need it, is negative 5. That's what they're talking about. You just go back to the original. No completion of the square, none of this mess needed. Unless I ask to show completion of the square. By formula, the vertex can be easily found by negative b, and b is negative 3, over twice a, twice 2. Please tell me, does that turn into positive 3/4 right now? Is this a negative times a negative positive? Is that 3 over 4? Is that what we got down here? Now the other part, I may have made a mistake. The other part says, if I'm correct, you can find the second coordinate, if this is correct, I hope it is, by using that formula, and I'm going to use it. Guys, it says 4, A is 2, C in this case was negative 5, and this is the one that scares me. Subtract b squared, oh my goodness, that's negative 3 squared, all over 4 times a, 4 times 2. This one's obvious, 3/4, checks. This one, oh, I'm hoping. This one, Michael, if I use the formula over there and I crunch all this out, it had better give me that number. If it doesn't, I've done something wrong. And we're going to close down class and leave. With my head hanging down in shame. Now, who knows, I may have made a mistake. Just crunch it out. This much is negative 40. Do we agree? Subtract. This, when you square it, is 9. Please tell me, is that negative 49 on top? 4 times 2? 8. Does that give you the same answer? When I construct the test, I'm working on it already. I'm still working on it. I finally finished the construction test. Would you prefer me to ask you to find the vertex and turning point and all that business? Would you prefer me just to leave it open, or in fact maybe say use the formula? Would you prefer to do this than all this? I'm going to ask you to do both. So you have to know how to complete the square to get to this vertex, and then a shortcut, use the formula, plug in your A, B, and C, get the numbers quickly, and you're done. Okay, so you have to know both. How to use completion of the square and also how to use the formula. Now, before I try to finish this up, just lose time here, can anyone tell me what bothers me about this? This is a formula. You have enough formulas in your mind right now, as if you need another formula. This bothers me. I don't like to use this particular formula, 4ac minus b squared over 4a. It works. You can use it. I'm not saying don't use it. It works. But for me, it bothers me. Why? Why do you think Professor Ramsey usually stays away from it, even though it does work?
You could just plug in X.
No, it reminds me of something else.
Quadratic formula?
Yeah, the quadratic formula was b squared minus 4ac, wasn't it? Now it's 4ac minus b squared, it's turned around backwards, and sometimes I get those two mixed up. So another way to find that second coordinate and this is a little lengthy, and not memorize this mess, and not plug in the A, B, and C that you need over here and find that second coordinate, a faster way would be, can anyone tell me a faster way to find the second coordinate, if you wish? You can use that formula if you wish. But if you do not want to use this formula here to find, where was it? This, what would be a quick way to find it without 4ac minus b squared over 4a, even though it works? Go for it.
Should I plug that 3 and 4 into f of x?
Do this. He said, Professor, you've already found 3/4. Just go back to your function and be patient. And you don't necessarily have to use this, Professor. You can. Just take it back to the function, plug in 3/4, and guys, this was what, 2x squared. He says, do this if you wish. Subtract 3 times 3/4. Did a lot in class tonight. Subtract 5. I think that's what you're telling me to do. Now if I crunch that out, I should get negative 49 over 8 again. Let's see if I do. This is 2 times, this is 9 over 16. This right here is negative 9 over 4, subtract 5. I can cancel 2 and 16, make that 8. Guys, you see right now I need a common denominator. So subtract 9 over 8. This changes to an 8, 18 over 8, I guess. And this is 40 over 8. Everything in terms of 8. If I put all these together with a common denominator of 8, please tell me, is that negative 49? So you could, without using the 4ac minus b squared over 4a, you could just plug it in. Thank you so much. Just plug it in directly, find the second coordinate. I see some looks like, how on earth? I'm supposed to move to math 7, which is a different course, Professor, eventually. That's a more stressful course. They're passing out the hallways in math 7. Students are passing out. Paramedics are coming in. The SMC, they're saying, what's wrong? Ramsey's class. I need a paramedic on the outside. Gee. Now, does it all make sense? I know you might be a little tired, but when you start preparing, studying, and you look at this, you say, oh my goodness, Professor, look at this mess. We did this, I follow you now, so it's got a little rest, and then eventually the formula works. Okay? Now, here's where I'm closed down. Just enough time here. Here goes. Is this the one that was on the handout that was worked out? Oh, this was not worked out. Beautiful. Just waiting to finish class up. Now, you've done all this business. If I say use completion of the square, you gotta do it this way. If I don't say anything at all, just sketch. You may use this formula to find your turning point. So if I say use completion of the square, I want to see the whole mess there. Now let's graph this, and I'll feel good about tonight. Where you guys here goes, and I'm going to recap on this, of course, before your exam takes place on Wednesday. Okay, let's say graph it. Go to a grid. I know the turning point. We're going to plot that turning point before I forget. It's out 3/4, down 6 1/8. Put some numbers here. Just get an idea. Okay, 1, 2, 3, 4, 5, 6, 7. This is 6 here. This is 7. 1. Okay. The guys out 3/4, down 6 1/8. Let's say it falls somewhere in here, just a little bit below 6. This is my vertex, my turning point. 3/4 to the right, like a horizontal shift, and down 6 1/8. Are we okay? Make sure, because it's working out, is it? Yes, no? Okay, that's my turning point. The parabola should be opening up. No problem. Now, as I open up, Michael, if I say open up, you may say, Professor, just do this. Go down to your vertex, turn, that's why they call it a turning point. Turn, and go back up, and there it is, Professor. But I want a nicer graph than that. That's the shape it's going to take. I'd like to know, besides doing this, is it going to cross the x-axis? Is it going to cross the y-axis? So on the test, you have to find this, the precise x-intercept, and this. I need those plotted also. How does one find the x-intercept? Always. You set the function equal to 0. I will keep it in the original form. I think it's going to be easier for us to set this function equal to 0, and you have this. We'll get this graph done. This is cute. I got to solve that equation. Thank goodness this one factors. You got this 2x, x, minus 5, let me step back, plus 1. Oh, it does factor. Spread this up, set each one equal to 0, guys, and solve it. I'll do it quickly since I'm limited on time here. We're going to get a 5 halves, 2 1/2, and you'll get a -1. Those are my x-intercepts. So we'll plot those. We'll use a different color for the x-intercept. One is out at 2 1/2. Put a 2 here, 3, it's right in here, 2 1/2. The other one is supposed to be added, if I'm correct, -1, over here. Those are x-intercepts. Done. Y-intercept. How does one find a y-intercept always? You go through and replace all the x's by 0. Which is easily done. If I go back here and replace all the x's by 0, guys, and crunch it out, he's at -5. That's it, right quickly. Professor, plot this. This is your y-intercept. Okay, 0's here. So let's drop down 5. 1, 2, 3, 4, 5. It's right here. -5, -6. Okay, 1, 2, 3, 4, 5. Now, do I have enough now to connect and get a nice graph? The parabola should sweep down, pick up this x-intercept, pick up that y-intercept, sweep on down, hit that turning point, and that's why they call it a turning point. It's going to turn. And what it's going to do, it's going to turn and right, come back up and pick up this x-intercept. And there is the graph done. Does that make sense? And guys, let me go ahead and make this look nice. This vertex was out, where was it? Out 3/4. And down 49/8, 6 1/8. There's the graph. Now, could we do that Wednesday? That's the graph of this thing right here. This is this picture. This is graph. Now, someone tell me before I close down, did I have a few questions about it after we got the graph? Did I ask for the domain? Usually I always ask for the domain. Guys, from left to right, you know the domain is associated with the axis. So along the x-axis, I don't see any gaps, holes. So it looks like it's everything can be used. Range though, the up and down, how far down does it drop? To a negative what? 49/8. And how high up does it go? Forever. written like this. Put a bracket on that, negative 49 over 8 through infinity. Is that true? What else did I ask besides domain and range? There, I always ask for that. When is my function guaranteed? Now guys, right, look at the graph. Here's my function. Now I'm asking, what x's can you replace here? What numbers can you put in for x? And you're guaranteed you're gonna get a negative answer. Guaranteed. All you have to do is look at the graph. It says, where is my graph below, less than, below the x-axis? It looks like, I hope I don't mess up, this is the piece that's below the x-axis. Now, can anyone describe to me on the x-axis from where to where is that happening? From what? -1 over to, what was that, 5 halves? From -1 over to 5 halves, it's like this. You're guaranteed, you plug a number in, caught in that interval here, you're guaranteed the answer is going to be negative. That's what that means. Guaranteed you're going to get a negative answer if you stick to that interval. What else did I ask? The minimum value of the function. Here we go, guys. This thing does have a minimum. All they're looking for is the y coordinate. You name the full vertex, I'll give you credit. So right here is the least, the minimum value that graph takes on. -6 and 1/8. Now, was that it? We did a good job. Did we do a good job on this? Oh, beautiful job. Now, can we do this Wednesday? I see some heads nodding yes. I see some heads like, where am I? Where am I? Is this a math2? Recount? SMC? Come on now. Gotta do one of these. Now before we leave, I've got your quizzes we're trying to do. Can anyone give me a guess? Just a guess. If I should ask you now, quickly sketch the graph of this. This is going to be science. Absolute value of my function. Then you now sketch. I have the function. Now sketch the absolute value of that function. Someone tell me quickly, what would you do? And you're going to be surprised how easy this one would be. No, I don't realize you want a graph. I don't want you solving anything. Just graph it. You have the function itself. Now I'm wondering what actual, those bars, absolute value have on that graph. Absolute value always comes out to be what type of a value. So if there's any part of this graph below the x-axis, I can't leave it there. Everything should be above the x-axis for absolute value positive. So all you need to do is lift this part up here, which should be more precise than what I'm going to do here, and make it look something like that. This part will be missing. This stays where it is, that's above. This stays where it is, that's above, that's positive. And then this has to be lifted above, and therefore the absolute value graph would be that on top, where everything's above the x-axis. That's all the absolute value would do to it, the rest of the graph, the absolute value of the function. Trying to get you ready for Math 7. I'm telling you, those Math 7 students, I have colleagues, they're crying. Being honest. It makes you cry sometimes, doesn't it? They're teaching calculus. They're not bad professors. We have wonderful professors here. It's just the material. Just the material, so I gotta get you ready. Guys, any concerns here? Any questions? Okay. Now, you guys who were with me at 4 o'clock, you got your quiz back. You may leave. Unless you wanna hang on a little bit later and question. But you may leave, I just need to get the cleaning back.